Hello and welcome back to Higher Maths, Polynomials and Quadratics. We're looking at synthetic division again. We're going to use synthetic division to factorize cubics in this video. So just going back to the end of the last video here, we had used synthetic division and we discovered that these values give x squared minus x minus 20 here. So what we could do here, rather than just multiplying out just to check that it does give the original function of x, is we could actually factorize further. That would break down to x minus 5, x plus 4. So x plus 2 bracket x minus 5 bracket x plus 4, we would have fully factorized the cubic there. Okay, so at National 5 we looked at factorizing quadratics. Remember, when we put a quadratic into double brackets, that gives us the factors. So we may have x plus 1, x plus 2 equals 0. So those brackets are called the factors. And from there, to find the roots or to find the values of x, when f of x equals 0, we'd just solve the bracket equals 0. So if x plus 1 equals 0, x equals negative 1. Okay, if x plus 2 equals 0, then x equals negative 2. So the factors of the brackets, the roots are the values of x for which f of x equals 0. So we're going to be using that in question 2, 3, and 4. So show that x minus 4 is a factor of f of x here. So if x minus 4 is a factor, that means x equals 4 as a root, because if x minus 4 equals 0, then adding 4 to both sides, x would be 4. So we need to perform synthetic division with x equal to 4. So the 4 at the front, write down all the coefficients, bring the number down, multiply by the 4 at the front, add them together, multiply by the 4, add them together, multiply by the 4, add them together, multiply by the 4, put them in, add them together. So f of 4 is 0. We have a remainder of 0 there. F of 4 equals 0. Therefore, x equals 4 is a root, and x minus 4 is a factor. So we have shown what we've been asked to show there using synthetic division. Let's have a look at question 3 here. So here's one without an x squared term. So remember, if this is the case, in our table, we must write 1, 0, negative 37, 84. So show that x equals negative 7 is a root of f of x equals 0, and hence fully factorize f of x. So negative 7 at the front, again, number down, multiply by the front, put the number in, add them together, multiply by the front, put the number in, add them together, multiply by the front, put the number in, add them together, and we get a remainder of 0 again. So f of negative 7 equals 0, therefore x equals negative 7 is a root of f of x, and x plus 7 is a factor. So I'm not actually asked to show that x plus 7 is a factor there, but I'm stating that because I am using that factor there. So x plus 7 multiplied by x squared minus 7x plus 12 will get me back to x cubed minus 37x plus 84. So now the question says fully factorize, so I can factorize this. Okay, so this is where all of that practice and the essential skills comes in handy, because most of you guys will be able to factorize this dead quickly. So we're looking for a pair of numbers that have a product or that multiply together to give plus 12. And then when we're multiplying the outside and the inside terms, we need to get the minus 7x term here. So x multiplied by minus 4, minus 3 multiplied by x. And we are going to have a look at this example and a few more in the next video.